Hello everyone. I want to welcome you to my channel. So today I'm going to work out more dosage calculation, and just like I did in the previous videos, I do not have the software to calculate it on your screen for you to see. So I'm going to be moving from the computer. I read the question and then I'll bring it to my table here, and then I will solve it with my pen and my paper, and my calculator is right here. So bear with me. I hope that in the near future I'll be able to get the software that will help me to solve it right on your screen for you to see. So today we have some interesting questions for dosage calculation, and it deals with drop factor. So one of viewers wanted me to do a little bit of drop factor dosage calculation. So I got me some questions online, and then from my school as well, because every semester we do dosage calculation. So let's get into it. Thank you for watching, for subscribing, commenting, sharing. Let's keep on sharing so we can build this community together. All right, so the first question is here. So read it with me and let's look for, let's see the values or what exactly the question is asking us to do. It says a healthcare provider prescribes 1,500 ml of normal saline to be infused over 7 hours. The drop factor is 15 drops per ml. The nurse should set the flow rate of the IV infusion pump at how many ml per hour and drops per minute. So it's asking for two answers. How many is going to be for the per hour, ml per hour, and then drops per minute. Okay, so these are our values. We have 1,500, we have 7, and we have 15 drops per ml. So let's come to the table and let's look for these two answers that they are seeking for. All right, so I bring you to my table here. All right, and I'm going to solve it here. All right, so what do we have? Now remember that when you see the word drops in dosage calculation, is GTT. That's the symbol for it. So drops per minute is one of the things that we are looking for. And then ml per hour is another answer that we are also seeking. All right, so let's get our values here. Okay, what is the drop factor? What is the drop factor? It says 15 GTT, which is the drops over 1 ml, times what is the prescribed value is 1,500 ml. Now always remember the unit of measurement that was required or that is being asked of you always be at the top, will come at the top, so your solution will be right. Always remember that. So because we are looking for drop, that's why the drop is up here. So it's 15 drops over 1 ml times the prescribed value, which is 1,500 over 7 hours. Okay, now we want it in minutes. So what is going to happen is that we have to convert these hours into minutes. So 1 hour gives us 60 minutes. Okay, hour will cancel the hour, ml will cancel the ml here. What are we left? We are left with a drop and we are left with a minute. So let's put them together by the calculation. So I take my calculator and I do 15 times 15 ml, and that will give me 22500 divided by 7 times 60. That will give me 420 minutes, and this is GTT. Okay, I hope you are following. All right, so 225 and then divided by 420 should give us, this will give us 53.5714 in some numbers. But what is it telling us to? It says round your final answer to a whole number. Okay, so the answer will be 54 drops per minute. 54 drops per minute. All right, the second answer they are seeking is the ml per hour. So let's come back here. What are they asking about? Okay, so let's solve for the ml per hour and see what we will get. So 15 ml over 7 hours. So let's divide it and see. 15 ml divided by 7 hours will give us 214.28 ml per hour. To the whole number will be 214 ml per hour. Now, when they are asking for ml per hour, it means you are not using the drop factor. It's going by the automatic, the infusion pump that doesn't require a drop factor. When you're doing it manually, it requires the drop factor. But when you're not using that manual one, and you are using the one that you can set it automatic, then it becomes ml per hour. So I hope you get the difference. So 1500 divided by 7 hours give you 214 ml per hour by the infusion pump. Okay. If you didn't get it, repeat the video and watch it again. I'm going to go to the next question. What does it say? A healthcare provider prescribes 1200 ml of 0.45 normal saline solution to be infused at 125 ml per hour. The drop factor is 12 drops per ml. How many drops per minute should the nurse adjust the flow rate to safely administer the prescribed intravenous solution? All right. Don't let this thing here fool you, because this here has got nothing to do with your calculation. This is just telling you have normal saline. Okay, what we concentrate on is your 12 ml here, and then the rate given here, and then the drops given here. So what are we looking for? We are looking for drops per minute. So let's come to the table and solve it. All right. When we come to our table, we are looking for drops per minute. Okay, this is what we are looking for. Remember, if that's what you are looking for, the drops will always come to the top. So let's go for our drop factor. 12 GTT over 1 ml. All right. So you see that's the first setup you get before you add the other digits to it. Okay, so the 1200 that is given they've already given you the rate that is going to get a total of 1200 ml. So don't let that also confuse your mind. So we go for the rate, which is 125 ml over what? 1 hour. All right. We want it in minutes, so we have to convert this hour. So it's going to be 1 hour over 60 minutes. The hour will cancel the hour. The ml will cancel the ml. We are left with the drops, and then we are left with the minutes at the bottom, so that our answer will come up to give us drop per minute. So let's multiply 12 by 125. when you multiply 12 times 125, you come up with 1500 drop over 60 minutes. There we go. So 1500 divided by 60 should give us 25 drop per what minute. I hope it makes sense. Okay. The 1200 ml was the total volume of the normal saline. Its rate is what we need to calculate to get a drop per minute. Okay, so it can be very confusing because you wouldn't know which of the values you are going to use for your calculation. But try to understand that it says it is to be infused at. So that is the rate you are dealing with. Okay, all right. Let's go to the next question here. Let's go to the next question here. It says a nurse was assigned to the medical surgical ward to care for a 30-year-old female diagnosed with pneumonia. The patient's primary healthcare provider prescribed 250 ml of D5W to be infused over 2 hours and 45 minutes. The drop factor is 60 drops per ml. To safely administer the prescribed IV solution, the nurse should regulate the IV drops for how many drops per minute. Additionally, compute for the ml per hour. So if you see the question like this, it can be very confusing. But don't let it confuse you at all. Just look for the values provided you and see how you're going to set it up. You've been given this drop factor, okay? And you've been given the prescribed volume and the time, 2 hours, 45 minutes. We need to convert it. Okay? 2 hours, 45 minutes. We just have to convert it. We need it in drops per minute. So the 2 hours portion need to be converted to minute, added to the 45 minutes. Okay? Don't let it confuse you. All right, let's go ahead and fix it on the table. We bring it here to the table. All right, let's bring it to the table here to solve it. Okay, so let's deal with the time first. 2 hours, 45 minutes. I hope you can see 2 hours, 45 minutes. So 1 hour is equal to 60 minutes. Okay, and we have 2 hours. So it's going to be 2 times 60. Okay, 2 hours is going to give us, if more, let's divide. 2 times 60. So that will give us 120 minutes. Okay, plus this 45 minutes. That will give us the total time in minutes. Okay, let's put it together. That will give us 165 minutes. That's the time that we just calculated. Drop factor is 60 GTT over what? 1 ml. And then we have multiplied by 250 ml over 165 minutes. Okay, ml will cancel the ml. We are left with the GTT and the drops and then the minute here. So let's calculate. 60 multiplied by 250 will give us 15,000. 60 times 250 gives us 15,000 drop. Okay, that's 165 minutes. Okay, so let's divide it. Divided by 165 That will give us 90.909. And what is it telling us? It says that we should leave our answer, our final answer in a whole. We should leave our final answers in what? In a whole number. So leaving this in a whole number will give us 91. If we want to put it in a whole number, drop per what? Minute. Okay, 91 drops per minute. If you want to round it up to the whole number, this on the 10th place is 9. It's more than 5, so you add 1 from here to here, and that becomes 91 drops per minute. Okay, so that one is the drops per minute side of it. All right. Now the other value they wanted was the ml per hour. Okay, they wanted to see it in ml per hour. Let's deal with the time again. The time is 2 hours and what? 45 minutes, right? Okay, we have to convert this 45 minutes to 1 hour. To an hour, and add it to this, okay, to get the total hours. 1 hour is equal to what? 60 minutes, right? Therefore, how many hours will give us 45 minutes? You cross multiply, okay? Minute will cross out minute. So we are done with minute. We need an hour. So 60x is equal to what? 45. Then you divide by 60. So x hour is equal to 45 divided by what? 60. Now 45 divided by 60 will give us what? 0.75 hour. So you add the 0.75 hour plus your 2 hours. Okay, and that will give you 2.75 hours as your total hours. You get it? The 45 minutes converted to an hour is 0.75 hour. Then you add your 2 hours. That will give you 2.7 hours. Now, if they are asking for ml per hour, what we're going to have is the 250 ml divided by 2.75 hours. Okay, so 250 divided by 2.75 will give us 90.90, and that will give us 91 ml per hour. Okay, so it's the same as this one here. This one is the same as that, and that's how you solve that. All right, you can re-watch this part till you get it. Let's go to this question here, and I will end the video because I don't want it to be too long, and then I'll pick up another section and continue with it. It says the nurse follows through an order to infuse 250 ml of platelet, I believe that's what they tend to write, IV over 2 hours and 30 minutes. The drop factor is 10 drops per ml. To safely administer the order, the nurse will set the flow rate of the IV pump at what ml per hour, additionally at how many drops per minute. So we are looking for 2 answers, and we are rounding it to whole number. So just as I did with the other one, the previous one, let's try to convert our time. Okay, let's try and deal with the time first. We want the time in minutes so we can get a drop per minute. Okay, let's go and deal with that first, and then we know that we have a drop factor of 10. So let's bring it to the table here. All right, let's bring it to the table. Okay, so in bringing it down here, all right, we are looking for drops per minute, and then we will do ml per what? hour. Okay, we are seeking two answers. We have 250 ml. We have drop factor of 10 GTT per 1 ml. And then we have the time. We have the time as what? 2 hours, 30 minutes. Okay. And I'm going to go through again. 1 hour is 60 minutes. Right? 2 hours will be twice of the 60. 2 hours will give us 120 minutes. Okay? So 120, and then we add the 30 minutes to it. 120 plus 30 minutes to get the overall minutes that is needed. Okay, so 120 plus 30. That will give us 150 minutes. Okay, so that's 150 minutes right there. 150 is what we have as our total. Now let's add them. So our drop factor is 10 drops per 1 ml multiplied by 250 ml. Okay, over what? 150 minutes. The drop is up because that's what we are looking for. ml will cancel ml. And then 10 multiplied by 250 will give us 2500 over 150. So drop, and then this is what? Minute, which is what we are looking for. Now 2500 divided by 2500 divided by 150 should give us 16.666. A lot of 6 drops per minute. So into whole number, we will add 1 from the 6 and add it to here. We will have 17 drops per minute. Okay, that's what you're gonna get, 17 drops per minute. All right, now we are looking for ml per what? Per hour. Ml per hour. Okay, so in calculating this one, ml per hour, what are we going to use? Like we did in the previous question. We already have our 250 ml. Okay, the time is what we change. Time is what? 2 hours and 30 minutes. Okay, now let's convert this 30 minutes to hour. Okay, let's convert it to hour. 1 hour gives us what? 60 minutes. How many hours? We don't know, so we put X. Will give us 30 minutes. We will cross multiply. Okay, so 60, the minute will cancel minute. So 60x is equal to 30, and then we'll add the hour here. Okay, 60 go to 60, and then 30. You cross multiply, you divide. This will cross out this, so x will be what? Let's see, 30 divided by 60 will give us what? 0.5 hour. Okay, so this 0.5 hour plus the 2 hours, what is it going to give us? So we're going to end up with 2.5 hours. So 0.5 plus 2 is going to give us 2.5 hours. Okay, so 250 ml divided by 2.5 hours should give us what? 250 ml divided by 2.5 hours give us 100 ml per hour. So this is the rate is going to go 100 ml per hour. And if it go into drop factor, then it's going to do 17 drops per minute. And with this, we end this dosage calculation of drop factor. I hope you enjoyed it. View it many times till you get understanding, and if it didn't make sense and you have a question in any of the things that I solved, you can reach out by comments. And don't forget to check out my Patreon link in the video description and support this channel, because I have a lot of resources to share, and as you support, I'll be able to get more time to share the resources and other things that you may need in your nursing journey, motherhood, and other things in life. All right, I love you all.